Hello students. Welcome to your school YouTube channel. Today's topic is, why does a rainbow exist only in a narrow band? So without wasting time, let's quickly start the video and learn. Rainbows are among nature's most beautiful and enchanting phenomena. But have you ever wondered why a rainbow appears as a narrow arc in the sky instead of spreading widely or covering a broad area? The answer lies in the fascinating physics of light and how it interacts with water droplets in the atmosphere. The basics of a rainbow. A rainbow is created when sunlight enters a raindrop. Bends, refracts, reflects off the inside surface of a drop, and then bends again as it exits. This process splits the white sunlight into its constituent colors red, orange, yellow, green, blue, indigo, and violet due to the different wavelengths of each color refracting by slightly different amounts. This phenomenon is known as dispersion. The role of angles. What's critical to understand is that this process happens at very specific angles. For a primary rainbow, the most common type, the light that emerges from the raindrop is most intense at an angle of about 40 degrees relative to the direction of the incoming sunlight. This angle is not random, it is determined by the physics of how light refracts and reflects inside a water droplet. Because of this fixed angle, a rainbow is not a physical object located at a specific distance. It is a circular arc of light that appears only when your eyes, the sun, and the rain droplets are all aligned just right. The band of the rainbow is formed from countless raindrops that happen to be at just the right angle from your line of sight. Why it's narrow? Here's the key: only the raindrops that are at this 40-degree angle for red light or slightly less, around 40 degrees for violet light, will send refracted light to your eyes in just the right way. That's why the rainbow appears as a narrow band. It's made up of only those droplets that fall within this very small angular range. Raindrops outside of this narrow angle don't contribute to the visible rainbow because they send light at the wrong angle to reach your eyes. Thus, the rainbow doesn't spread across the sky but forms a narrow, curved band instead. The color order and thickness. Each color in a rainbow corresponds to a slightly different angle. Red light bends the least, it appears on the outer edge, while violet bends the most and appears on the inner edge. This difference in angles about 2 degrees defines the thickness of the rainbow. So, the width of the rainbow is essentially a reflection of this range of bending angles from red at 40 degrees to violet at 40 degrees. Your position matters. Since the rainbow depends on the angle between your eye and the sun, everyone sees their own personal rainbow. Even if you're standing next to someone, you're seeing light reflected from different sets of raindrops. And because the Earth blocks the bottom half of the 360-degree rainbow circle, we usually only see a semi-spherical course unless we're in a plane or on a mountaintop, where full circular rainbows are sometimes visible. Conclusion: a rainbow exists only in a narrow band because of the precise angles required for sunlight to refract, reflect, and disperse within raindrops to reach your eyes. This optical geometry allows only a small section of the sky to display the colorful arc. It's a beautiful example of how physics and geometry come together to paint the sky with color not across its entirety, but in a delicate, precise, and inspiring band. Hello students, let's get to know me. The type of videos I make here are very important for your school, college, and higher studies. I do a lot of research and find answers to your questions. But for physical problems, I make voiceovers through AI. I upload 3 videos here every day. If you have any problem, please comment and let me know what your problem